Hello. In last class we have discussed about auto transformer. Today I will discuss the basic problems of auto transformer. Here we have a problem in which problem is that a 20 kVA 2300 to 230 volt 2-winding transformer to be used as an auto transformer with constant source voltage 2300 volt. At full load unity power factor, calculate the power output, power transformed and power conducted. If the efficiency of 2-winding transformer at 0.6 pf is 96%, find the auto transformer efficiency at same power factor. This is the question. For this, in given question, there is a 2-winding transformer and we have to make a auto transformer with the help of this 2-winding transformer. For this, we have to analyze 2-winding transformer first. For the 2-winding transformer given, ratings of 2-winding transformer which is given S is rating of kVA is equal to 20 kVA and V1 is given 2300 volt and V2 is given 230 volt, or we can say N1 by N2 is given 2300 by 230 volt. Now we want to find current in primary winding and current in secondary winding of 2-winding transformer. We all know that I1 is the kVA rating into 10 to the power 3 by V1 will be I1, and similarly I2 will be kVA into 10 to the power 3 by V2. So I1 is equal to kVA is the 20 kilovolt into 10 to the power 3 and V1 is 2300 volt, that will be 8.96, and I2 will be 20 into 10 to the power 3 upon 230 volt, that will be 8.69 ampere. This is I1 current, this is I2 current, and this is dot of winding second and this is dot of winding first. Dot sign shows the polarity in windings. Now we want to make auto transformer. See, in primary winding in 2-winding transformer, if there is a primary winding name as AD and this is the secondary winding name as AC, and we want it connect at 2-winding and we want it connect as auto transformer, then we have to connect this point B to D for getting auto transformer. Then this is winding AB and this is winding AD, this is winding AD and this is winding BC. Here we have connect D to B for finding auto transformer, and this is 230 volt primary winding and this is the secondary winding which is 230 volt, and this is primary winding which is equal to 2300 volt. As shown, this is dot in primary winding and this is dot in secondary winding. This is dot in primary winding and this one is dot in secondary winding. And then we have calculated current in primary winding is 8.69 and secondary is 86.9. Now if we consider about direction of current, then if we know that primary current will be opposite in direction whatever is secondary, it means primary current is opposite to secondary by direction. So if direction will in primary winding is upward, then direction will secondary winding is downward. If current in primary winding is leaving through dot, then current in secondary winding will be entering through dot. Here primary winding, here in primary winding, current is entering through dot, then in secondary winding current is leaving through dot. See here, if this is phasor diagram of auto transformer, then I1 is opposite to I2 direction. If this is a node D and applying KCL at this node, then both the current are going outside from this node. Then we have to add up this both current to finding the current in this arm. So you have to 8.69 and 86.9. Adding these both current, we get 95.59 ampere. Now, what will be voltage on secondary of auto transformer? See, this is the additive polarity. This dot and this dot shows plus minus, and this dot is shows plus here and minus here. These both polarity are additive, so you have to add this both voltage to finding the voltage across load. Now we have to 2300 plus 230 volt will be 25253 volt. For finding auto transformer kVA rating, we have to load voltage and load current. Then load voltage will be 2530 volt, which is here, and the load current will be 86.9 from this figure. Then the rating will be, what will be rating? VL into IL upon 1000. BL will be 2530 volt and IL will be 86.9. This will be 220 kVA. Similarly, input side voltage will be 2300 volt and current will be 95.59 by 1000. We can get 220 kVA. Apart from this, we have a formula: rating of auto transformer upon rating of two winding transformer is equal to 1 minus K. We have this formula. You can also calculate the rating of auto transformer if you know the rating of two winding transformer and K. Then we can find K from here. K is the N2 by N1. Here N2 is the 2300 volt and N1 is the 2530 volt. So K will be N2 by N1, which is always less than 1. It will be 2300 volt upon 2530 volt. It will be 0.909. And if we want to calculate 1 minus K, 1 minus K will be 0.090. Then rating of auto transformer will be rating of two winding transformer into 1 minus K, and from here we can also calculate rating of auto transformer is 220 kVA. Now kVA transform, what will be kVA transform? We have discussed power or kVA can be transformed in two modes in auto transformer. First is the transform mode and second is the conducted mode. Then what will be transform mode? What power will transform to transform mode? See, in this winding, this winding is responsible for power transform mode, and this will be responsible for conduction mode. This is conduction mode and this winding shows transformed mode. If you want to calculate transform mode, then this winding give transform mode power. Whatever is this power, in this voltage is 230 volt and current is 86.9. Then you have to multiply voltage and current divided by 1000. So in this, voltage is 230 volt and current is 86.9, and divided by 1000 you will get 20 kVA. And what will be here? KVA transform will be 230 volt divided in multiply into 86.9 divided by 1000 is equal to 20 kVA. And what will be kVA conducted? kVA conducted will be total power of auto transformer minus transform power. Then what will be rating of auto transformer? We have calculated auto transformer rating is 220 kVA, and whatever is power transform will be 20 kVA. Then 220 minus 20 is equal to 200 kVA. It means conducted power will be 200 kVA and transform power is 20 kVA. Now you have calculated efficiency of auto transformer. You all know efficiency is the output upon input, and input is the sum of output plus losses. You can calculate losses is equal to 1 upon efficiency minus 1 into output. Efficiency is given in case of two winding transformer, which is 96%. So 1 by 96 minus 1 is output. Output is given 20 kVA. Output is given 20 kVA, and power factor is given 0.6. Here kVA is equal kVA into PF is equal to kilowatt. So here losses will be 1 upon efficiency, which is 0.96 minus 1 into power in kilowatt. As you know, losses remains constant as in case of two winding transformer, whatever is in auto transformer. Losses remains constant in auto transformers too. So efficiency will be 1 minus loss by input. From here you can calculate efficiency will be 1 minus loss by input. You have calculated loss is equal to 500 watt. So here 500, and the input will be, in case of auto transformer, 220 kVA multiplied by 0.6 will be gives watt. Gives watt, and this is loss. Input will be output plus losses. So put here losses, and this is input of auto transformer in kVA. This is power factor, and this is loss. That will be 99623%. No, not percentage. Percentage will be 99.6%. Okay, thank you.